All right, good afternoon. I'm Tyler Wolfe-Driver. If you guys will go ahead and introduce yourselves, we'll get started. Whichever
I'm
one.
Hall. I'm Blake Sweeney.
And we worked on a advanced climate control system that utilizes not your regular temperature sensor, but also a light sensor. Has some very user-friendly indicators, and we're going to discuss both what we use to determine and develop this software and hardware, and also some of the hard points that we ran into and how we got around it using what we've learned in our previous classes. So just to start off, the project overall, like I said, uses a light sensor, temperature sensor. It uses those indicators in exclusive cases to display information to the user. So that's the user-friendly side. Um, and this design really spurred from just a industry trend of people wanting to know more um about their home, information about climate control in their home. Climate control in the world is a growing topic, and this is a way that we can, on a small scale, start to gather information and find ways to measure how a climate's affected by outside elements. And it's also kind of interesting because it's almost like a smart device, almost if you can think of brands like Google and Amazon, they have smart devices that go in your home that give you all sorts of information. And this is just a step ahead with a light sensor that works in tangent with the temperature sensor already to kind of hyper control the climate. That pretty much sums up our motivation. But some of the immediate applications that I would like to discuss are expensive paintings in a museum. Um, Sometime with the light sensor element, sometimes it's like, well, why not close the blinds? You have light coming in that's the UV rays, the radiant heat is heating the surfaces that the light is exposed to. That could be a painting, that could be an animal's habitat in an aquarium or zoo. And those uh, objects in those habitats may be sensitive to temperature changes even at the surface level. So to counteract that, you have these sensors in there that will engage either like a cold water pump or a fan, some sort of cooling system. And we just want to call it pretty much an output device for now. And we use the motor on the MyRio board. We'll get into that later. But yeah, that's the motivation. That's some of the applications and summarizes why we did this. Blake's going to take it away with the questions and methods and materials.
All right, so some of the initial questions that we started off with from the client side that helped our design process was what type of control should the system give you to define how the environment should be controlled? What type of information that it will give you, and what type of indicators that the system would need to make it easy to understand. And using these as a foundation to kind of go off of, the methods that we started out with were researching similar products, and we noticed that there was a gap in the market that we were able to fill with our project, or with like the project that we wanted to make. So we used those questions and that research in parallel with the materials that we were given, which we did a physical side and a program side. So we used the MyRio system for the physical hardware, and we paired that up with LabVIEW for the program side. And using these two together, we were able to create something that fulfilled the requirements based off of the initial client questions and filled in that market gap that we were shooting for at the beginning.
Now into the project description. Our application, as you stated, uses the MyREO board that uses sensors that would then be inputted into LabVIEW to trigger a fan or a pump just to cool or shade anything, or like Tyler said, a habitat, a painting, any sensitive area to climate. Um, we also took inputs from users that would then convert it into voltage to be compared through comparison blocks, logical gates, just to make the flow a little bit better uh, and show whichever process was happening at that moment. For the temperature, we put an on delay timer. This is due to spikes in the voltage from the sensor. So not so to eliminate that motor constantly being excited and stopping for like say an AC unit or something like that. we put an on delay timer so that it'd have to reach a certain span of time before it was actually kicked in. And then we also used indicator lights to make it more user friendly to see which process was happening at what time. For example, if there was too much light, a blue light would come on. If there was too much, if the temperature was too hot, a red light would come on. And if both of those were happening at the same time, a green light would come on to indicate that both those functions were happening at that time and activate those motors. And for the conclusion, our final product met the specifications that we strove for and that our customers uh, desired. Um, we tried to uh, figure out how to solve all their questions and everything like that. Some of the issues that we came into was the flickering of the temperature. That was took us a little bit of time to figure out how to manipulate the code so that it would function as desired. Also, the Boolean logical gates were a little bit tricky to get working to only do one process at a time. So if only the sunlight was going, like I said, that it would only show and only run that motor. And if both of them are on, it would show that green light and run both of those at the same time. And then and for the temperature, the red light and that AC motor.
It sounds good so far. You know, one thing that we kind of want to move towards, and I think that our design favors, is any kind of data acquisition uh, program. You know, the next step for this could be collecting consumer data and using that data to further fine tune our design to serve the function that we originally had a vision for from day one, which was, of course, to hyper control a climate to protect a product, to protect I say products, I say food, I can say animals, anything you can think of that is extremely sensitive to even the slightest climate change. That would be our market goal. And of course, the next step of that is to maybe in the future you want to implement data acquisition for the user that tells them how long this process runs due to this sensor and how long they run together and how much it costs. That's kind of the next step. But as far as our original market goals and our questions from our consumers and surveys, we were able to satisfy that with the functionality and the indication of the functionality of the sensor board. We've made it user friendly, and these next steps could be achieved fairly easily given the hard work that we've done so far. Thank you.